So question 146 here, using a numerical method called iteration. So the first thing we're doing is showing that the equation has a root between 2.6 and 2.7. So we find the value of y when x is 2.6, and that's a negative value. And then find the value of y when x is 2.7, and that is a positive value. On its own, that's not quite enough. We have to also make a statement that the function that we're considering, this function, is continuous over this interval that we're considering, and it is. It's a standard polynomial, no discontinuities. So the change of sign and the continuity of the function indicates that the root lies in that interval. So now we've got to show that we can rearrange the equation into this form. So taking that equation, starting off by moving the 7x minus 2 over to the other side, leaves me with x cubed minus 5x squared equals 2 minus 7x, because they've been moved over to the other side. Then I can factorize out the x squared, leaving me with x minus 5. And then I can divide both sides by this factor x minus 5. And finally, take the square root to give me the required form. Okay, so now we've got to use an iterative formula based on that rearrangement. So what we have to do is to change these x's to xn and this x to xn plus 1. So when we do that, that's the iterative formula that we get. So we're using an initial value now of x0 equals 2.6. And so we're saying if x0 is 2.6, then x1 will be the square root of 2 minus 7 times 2.6 over 2.6 minus 5. So that gives us a value for x1. This is rounded to 3 decimal places. Then we use this same formula again to calculate x2, but this time we're putting x1 here and here. And the x1 that I'm putting there and there is not this rounded number, but the unrounded number. So then I get that value. I'll repeat the process one more time with the unrounded value for x2 into this formula, and then I get a value for x3, which is that. So those are the 3 values that we're looking for, all rounded to 3 decimal places. And finally, we've got to describe the behavior of the iterative formula with that initial value. Well, we're trying to get a solution, trying to find the root that lies between 2.6 and 2.7. This value here is less than 2.6. We started at x equals 2.6, and we're getting further and further away from the root. So this rearrangement diverges from the required root. It actually converges on another root to this equation, which is x equals 2. All right, so there we are.